Welcome to a lesson with Dr. Powell. Let's take a look at how we can use matrices to compute a multiplicative inverse in a mod. So here we're going to take 11 bar, which is an element mod 91, and we're going to compute its multiplicative inverse. We know it has a multiplicative inverse because the GCD of 11 and 91 is 1. They don't share a common factor. Okay, so we can write down, we look at the Euclidean algorithm. We compare 11 and 91 via division with the remainder here. So 11 goes into 91 8 times, remainder 3. And then we repeat this process. See, it's 11 and 3. We kind of slide it down along this line. Okay, and then we repeat. 3 goes into 11 3 times, remainder 2, and then we slide down and then repeat. So in this process, notice we kind of notice the shifting mechanism going from 91, 11, shifting down to, so to 11, 3. And then the mechanism where we shift from 11, 3 to 3, 2. And then where we shift from 3, 2 actually to the next set, which is 2, 1, which I didn't write down here. But we're going from 3, 2 changes out to 2, 1. So each of these shifts, if you will, of ordered pairs can be represented via a matrix or matrix function. So for the first one, thinking of a column interpretation with like input, like right here, see this matrix right here? If we input 91, 11 into it, we would end up getting 11, 3. You can try that out. So 0, 1, 1, negative 8. You just plug 91, 11 into that. So notice, if you're thinking about rows, see this row right here? This just picks out, if you just take that row, multiply by this column, it just picks out the bottom element, 11, so it performs that bit of the shift. This right here actually does exactly, see this 1, negative 8? This right here, what it does is it takes, so 1 times 91, so 91, then minus 8 times 11. That's like moving this over to the other side of the equation, and you're solving for the remainder. So that gives you, the remainder gives you the next guy. So we just represented this shifting process mechanism as a matrix. Think of it as a function, the first function right here, and then composition, you plug the result that comes out of that into another function, which represents the next shift, determined the same way. And then you put that into the next shift, determined the same way. Notice how we can build these matrices. All of these look the same. See, 0, 1, 1, 0, 1, 1, 0, 1, 1, except these guys. What are those? Those are just the negatives of, or the opposite sign of the quotients that we have here. See this 8, 3, and 1, 8, 3, 1. So we can just put that down. We matrix multiply these together, and we get this matrix. This represents the full shift from 91, 11 to 2, 1. So you want to skip to the chase, just get right there. So, so we take this matrix, and if we plugged in 91, 11 into it, we would end up getting 2, 1. Okay, so if we're just looking at this part right here, okay, we're going to getting 2, 1. Now notice, how do we get this 1? By taking the bottom row here and this column, taking a dot product here, so 4 times 91 minus 33 times 11, and that's going to be equal to 1. So how does this tell us our inverse? Well, if you just look at this line and mod out by 91 here, so where everything becomes a bar, now specifically this mods out to 0, and so you have negative 33 bar times 11 bar, and we'll just go right to here, is equal to 1 bar. There's your inverse. 11 bar times negative 33 bar. So negative 33 bar wins. That is the inverse of 11 when we're thinking mod 91. Thank you for watching.